double think here. So, Tim Mornian, president of Titanium Marine Engineers, will talk on constructing a marine engine exhaust gas scrubber from titanium material, which is great. So, here's Tim's bio. President and owner of Titanium Marine Engineers, located in Conroe, Texas. The company fabricates shell and tube heat exchangers with an emphasis on using titanium in marine applications. In 1988, Tim delivered his first titanium tubed unit for refrigeration service aboard a large commercial fishing boat. These titanium condensers and chillers solve the problem of saltwater corrosion and have become the accepted solution for marine refrigeration globally. Very good. Tim's career has always had an energy and marine focus, starting with his post-college years, working as a marine engineer aboard an offshore drilling rig. He obtained the rating of Marine Chief Engineer and then returned to shoreside employment. Working at the Southern California Gas Company as a facility engineer, Tim gained further exposure to the corrosion resistance of titanium while working with alternative energy sources like biogas, geothermal, and district heating and cooling. 1988, Tim opened his company, and the first units were delivered to fishing boats operating in the Western Pacific Ocean. Specialization in titanium has led to subsequent solutions for main engine cooling, live seafood refrigeration, and most recently, diesel engine exhaust treatment. With over 35 years in the marine and offshore drilling sectors, Tim has leveraged the corrosion resistance of titanium and the presence of seawater. He holds a BSME and MBA from the University of Southern California and is a licensed Marine Chief Engineer. Lives in Magnolia, Texas, remains focused on expanding the uses of titanium in marine and corrosive applications. So please welcome Tim.
Boy, I'd forgotten all that stuff. Okay, great to be here. I appreciate the opportunity to talk with you all. Thank Rob Henson for suckering me into this. He's held my hand while we pulled this all together. I will give you a heads up. I am an engineer, but I'm a sales guy. So the bulk of my career has been selling the attributes of titanium as opposed to designing. So while I buy a fair bit of it, at the end of the day, my focus, my presentation will be on converting people to it. So that being said, a year ago when I joined the IAC, the Industrial Applications Committee, the issue was, where else can we use titanium? And they looked at me and said, well, you got marine in your title, so what does that mean? So long story short, here I am preaching to the choir relative to the attributes of titanium in saltwater service, but at the same time, each and every day, talking to the marketplace and converting people over, getting past all the preconceptions, misconceptions, and competitive stories relative to titanium versus other materials. So the presentation is qualitative. It's not numbers based. It's something that reflects how I go to market, how I talk to people. The exhaust gas scrubbers came up because as we were casting about looking for a relevant target that would mean something going forward, coincidentally in the marine marketplace, deep sea ships right now, there's an initiative, a law that's being implemented that's going to change the market overnight, that night being January 1st, 2020. Specifically, we're going to go from having 3% sulfur in what is the common fuel being used by deep sea ships to 0.5%, so a six-fold decrease. And you can imagine what that does to the supply chain and to the quality control, and I would call it the law of unintended consequences because it is a big hurdle. I mean, you got to think globally. Ships don't come back to the same place for fuel. They go to wherever they are. So they take the fuel that's made locally. The reason is air pollution. So while it's a solution to pollution, it comes with its basket of problems. I would contend that titanium can solve some of those problems as it is evaluated relative to the current state of the art, materials being used, compared to what it can do in the same service. And that service is basically a sulfur-laden application, which with a little bit of water, you get a nice little cocktail called sulfuric acid. Okay, so that's the setup. It's a long presentation, but we should stay under the 20 minutes. So how do we do this, Chuck? Oh, that one. Okay, well, here we go. That one? Okay. Oh, yuck. Can we dim the light? Is that possible? I intentionally made these things readable from the back of the room, but I didn't expect this much. So anyway, we're going to go through it. As I said, this is qualitative. This is a conversation starter. This is what I would do if I met you in a hotel lounge or something like that, and you asked me what I did for a living. So it's a conversation starter relative to titanium in marine service. Specifically, looking at using titanium for an exhaust gas scrubber. Who in the audience knows what an exhaust gas scrubber is in industrial or even in marine? Okay, so a fair bit of you. You know, shoreside, they've been around forever. In the marine business, they're a new kid in town. And that unit there, made by CR Oceanics in New Jersey, is 35 feet tall and 6 feet in diameter. Thank you. It's perfect. So that's a big boy right there. Now, it's essentially hollow inside, but we'll get to that. But again, the purpose of this presentation is to consider, if you will, using titanium in lieu of the current materials. So we're going to talk about it like a sales guy. We're going to talk about the pain, the solution, and the opportunity, as opposed to the matrix and ions and iron and all that good stuff that I truthfully am not qualified to talk about. So the pain. Here you go. You could go outside. The ship just passed. I watched it pass about 30 minutes ago, and while it wasn't that bad, I can guarantee you if it weren't in the public view, it would have been. So times are changing. We no longer tolerate that sort of stuff because there's over 100,000 ships at sea, and over 80% of the world's goods go by sea at some point in their life. So there's a lot of ships out there. They're burning a tremendous amount of fuel with a resulting tremendous amount of CO, NOx, and SOx. So that's no longer acceptable. The public is demanding that emissions be brought under control, and there's a governing body called the International Maritime Organization, IMO, that is global. It's not EU, it's not North America, it is global. All ships subscribe to the regulations relative to various life-saving, navigation, and now emissions. So we can no longer do this, or this, or this, or this, or this. Public's not going to stand for it. The rules changed January 1st. Well, what are the rule changes? Well, the ships that are burning this particular heavy fuel oil, which is called bunker C or number 6, contribute to a tremendous percentage of the world's annual production of greenhouse gases, CO2, NOx, and SOx, as well as particulates. The only reason they've gotten away with it for so long, or we've gotten away with it, I include myself, is because ships are out of sight, out of mind. Well, that's no longer the case. We know where every ship is, what speed it's going, what heading it's got. No more secrets, no more hiding. Hence, you can pass a regulation like this and hope that it'll be implemented. As I said, we're dropping from 3% sulfur to 0.5. Now, to comply, the ships are going to have to either burn light diesel oil, or they're going to burn heavy oil as they are now, but they're going to have some tail gas treatment or scrubbers. The deadline, again, January 1st, 2020. Is the industry ready? Is the supply chain ready? Are the ships ready? No on all of the above. So this is what it looks like. It has to be heated to even pump it. After the distillation of the light ends and the medium ends, et cetera, in the refining process, you have what's called residual oil or bunker C. And it's got caloric content. You can burn it. It makes a great fuel, but it's kind of dirty and its days are coming to an end. So how do you reduce the emissions? You've got various options, as I said. You can burn the marine gas oil, and there's obviously going to be a downside, but it's very clean. or you can continue to burn the heavy oil, but you've got to do something with the emissions. And we're not just talking the black smoke. There's a transparent haze that comes with every ship that's burning heavy oil. Now, what's the delta? What's the motivation? Well, last week on the commodity exchange, light oil was $6.65 a ton, heavy fuel oil, the current solution, $3.98, with a delta of 40%, and annualized for a ship that's sailing 300 days, burning 70 tons a day a year, almost $6 million. So that's real money, right? People are motivated. I mean, I talk to these people all day long, and, well, we're going to do this because it's environmentally friendly. Then they look at the solution and they say, well, maybe we'll examine staying with the heavy oil. I guarantee you this will hit the news right after the first when ships can't get the oil that they want. So again, we have a 40% premium for taking the easy way out, and that's a non-starter. So the solution, and I'm looking at the clock here so I don't carry you into tomorrow, is exhaust gas scrubbers. Now, technically, chemically, physically, they work great. There's three types: open loop, closed loop, and a hybrid. I'm going to talk only about the open loop because it's the most simple, easily understood, and from a material standpoint, the arguments are all the same. This is three of them waiting to be fitted onto a cruise ship, which is what you see in the background. Those are, again, about 35 feet by 6 feet, and they're not small, they're not heavy, but there's some intrinsic liabilities. So here we go, standard issue scrubber being keel hauled onto a ship. The problem is that 100,000 ship quantity that I referenced, they were designed and built without these things in mind. So how do you put 6 pounds into a 5-pound ship? It's a real hassle, and it adds to the cost, which we'll cover. So how does a scrubber work? Well, it's a vertical cylinder, primarily hollow inside, light wall construction because it's low pressure. You can't put back pressure on an exhaust system. And it uses seawater and to knock down the sulfur. And it's a once-through system in this case. So if you look at the green arrows, in, up, through, it rains down vertically towards the bottom, and then overboard. And that raises a whole host of questions. Well, what about all that stuff you just knocked down? Are you sending it overboard? Yes, you are, but that's another presentation. That's somebody else's presentation. But it's as simplistic as it looks. You're taking all that junk, you're washing it down and throwing it over the side. Again, another presentation. So then it goes out the top, it's cooled off, you've knocked down the temperature, you've reduced some of the NOx generation, and it's fundamentally much cleaner. So the current material of choice, which is what I'm here to argue, is the super austenitic stainless steels. I'm told I can't use brand names, but use your imagination. So what are the issues surrounding the use of that material? Well, these are in high temperature service, and they're in very high temperature service when the water flow gets turned off. And we all are technical people. We know that that never happens, that things don't get run out of spec, but it should it happen. It heats these materials way up past their comfort zone, and that creates problems with service life. Well, then they've got a limited service life because they essentially begin to fail the day you put them in. And the word I get in talking to my colleagues in the shipping industry is that 5 to 7 years is the expected life. Well, the nominal life of a ship is 20 to 25 years, and that's before they start to go into life extension. So you can see that you're going to be replacing these things, and we'll get to that. The other problem is when they are running out of spec, you create sulfuric acid, and it goes out the top in the form of acid rain. It goes through the cracks in the vessels as they fail, runs onto the deck and into the framing of the ship, and it actually creates a problem outside the hull. If you remember, I talked about pumping it overboard, and it's very low pH. Now, that's not when they're running properly, but these things don't run properly any more than anything else runs perfectly all the time. So the acid production impacts the material of choice. When you get to item 4, replacing these things is expensive. Going off of charter to do it is even more expensive. So that's a consideration. You know, you can pay me now or you can pay me later and later and later. And then lastly, if you are operating out of spec, you're no longer able to hide because they have continuous emissions monitoring, and you can be discovered and reported and taxed while you're still at sea. So all of these things are negatives relative to using a material that doesn't last a lot longer. So the opportunity is to build something out of titanium. So we're going to go into why titanium is a better material. A current scrubber looks like this on the inside. Basically hollow. It's got some nozzles at the top that spray the water down, and the alkalinity of the seawater interacts with the acidity of the gas, and you fundamentally, theoretically, in quotations, come up with a neutral fluid. They're installed in retrofit, which is going on now, or they're installed at new construction. So water in, water down, water out. Hot gas in, cooling down as it hits the seawater, cools down out the top. It's pretty simple. It's very effective. We're just looking for a material that's going to last a lot longer. Now, this is the extent of the numbers I'm going to hit you with. Right now, the end of the year, we expect that there'll be about 3,000 installed globally. As is always the case, people put it off and put it off and put it off. But in this case, unlike most cases, there is no grandfathering. The regulatory bodies are playing hardball. So if you don't have one in, you're a little bit under the gun. Estimates are that in 5 years, we'll have 30,000 total. Not everybody will go for it. There are other options. But taking that as an example, you can see that from a manufacturing or market opportunity, that's a lot of units. So do the math. If you're in the fabrication business, it's interesting. If you're in the shipbuilding business, it's interesting. If you're in the ship operation business, it's very interesting. You'd like to get it right. So what's a comparison? Well, in order to compare these, I wanted to keep it real simple. I didn't include any of the attributes. I didn't include any of the weaknesses of either material. I just said, bring me 2 vessels, 33 feet tall, 6 feet in diameter, make them exactly the same, and we'll see what they cost. So the comparison that we developed is for 2 vertical cans. We calculated the cost, material, welding, fabrication, transportation. And then we looked at the life cycle costs, recognizing that one of them, without question, has a limited service life. So here's the 2 materials, superaustenitic and grade 12 titanium. Tensile and yield are pretty close, so no big differences there in the actual design. Of course, one weighs half as much, and that's a big attribute. But when you get into the pitting temperatures, you can see that titanium can handle pitting at much higher temperatures. Crevice corrosion, the same, very high temperature compared to. And on the microbial influenced corrosion, resistant on the part of grade 12 and susceptible with the superaustenitic. So lastly, getting to the meat and potatoes, this is a very simple but I think defensible spreadsheet that shows if you were to make a unit out of superaustenitic and you were to make one out of grade 12 titanium, identical down to the last nut and bolt, you would have a CapEx for the scrubber with stainless at 200 units. 150% more expensive is the titanium. Okay, so we're at a big disadvantage if we stop the analysis there. You can see underneath the red number is 1,800 units, commercial units, dollars, krona, pick your currency. So to put them in is the same. But when you begin to get into operation, you see that every 5 years we're going to be replacing the stainless one. Over here, we're going to have, we equated a very limited amount of care and feeding. This is where the 2 lines diverge. So at the end of 20 years, you've replaced the stainless steel unit 4 times or 3 times, and you've never replaced the titanium unit. So you've got a difference in spend over the course of 20 years of 1,700 units. So that's it. I mean, that's a quick and dirty, meet the customer, convey to them the obvious differences. So you get lines that look like this. On the left-hand side, you can see that they quickly cross. The brown line is the titanium grade 2. The blue line is the care and feeding for the stainless steel unit spread over 20 years. And again, at the end of 20 years, you're up 1,700 units if you'd use titanium. So the key facts from all of this, the CapEx delta, the 150% more or 50% more, really becomes rather insignificant over the life of the unit. The replacement window for stainless, 5 years or 7 years, I've done it both ways, it doesn't change anything. If you are replacing them every 5 to 7 years, that comes with a cost for the out of service, for the logistics, for the actual process, and it adds up quickly. The assumption is that the right titanium material put into service, it should last the life of the vessel. It has with everything else that my company makes out of titanium. And the conclusions are that the ROI is recaptured in less than 2 years. That's the difference of 50%. The ships that are using exhaust gas scrubbers versus the lighter oil are going to save almost $6 million in a year. That's just a quick and dirty estimate. And if you want your classic economic experiment or example, pay attention to the price of the marine gas oil after the first of the year. The regulatory compliance costs are going to be minimized because you're going to stay out of the crosshairs. The maintenance, repair, and operational costs for titanium are going to be considerably less than the stainless. And that vessel owners, operators, shipyards, etc., really should consider looking at this market and looking at titanium in marine service across the board, because our experience after 30 years is the worst thing you can say about titanium is once you sell it, you'll never sell another one. And that, you know, worse problems could be had. But it's a great solution. We're looking for people, quite honestly, to take the plunge and to build one. And I believe that those individuals that take that challenge are going to be well rewarded. So that is the end of the presentation. Thank you very much.